Imagine you want to train a model to give better answers, but there is no formula for what better even means. You cannot write a loss function for helpful and honest, and you certainly cannot pay a human to grade every one of millions of training examples by hand. So here is the elegant trick at the heart of modern alignment. You train a second model to stand in for human judgment and let it do the grading for you. That model is called a reward model, and it is the quiet engine behind RLHF. Let's see how it works. First, let's see the exact problem this idea is built to solve. Grading every sample by hand simply does not scale. A single alignment run needs feedback on millions of generated responses, and no team of humans could ever score them all, one by one, fast enough or cheaply enough. The moment you try, the whole approach collapses under its own weight. This model learns to do the grading for you. Train it once on human judgments, and it can then score any new response automatically in a fraction of a second at essentially zero marginal cost. Human effort goes into a few thousand comparisons, and the model generalizes that taste to everything else. It becomes a stand-in for the crowd, always available, endlessly patient, and consistent in a way tired human labelers can never quite be. So how do we actually build one? Follow the recipe step by step. It starts with pairwise human preferences. We take a prompt, generate 2 responses, and ask people a simple question: which of these is better? That comparison is far easier and more reliable for humans than assigning an absolute grade, and we gather many thousands of them. Then we train the model to agree. Using those comparisons, we tune it, usually the language model with a scalar output head, so that it assigns a higher score to the preferred response than to the rejected one. The math behind this is the Bradley-Terry model. Once trained, it can score anything. Hand it any new response it has never seen, and it returns a single number estimating how much a human would like it. Suddenly, subjective human taste has become a fast, automatic, numeric signal, and that score becomes the reward. In the reinforcement learning step, the language model is optimized to produce answers that make this number as high as possible. A handful of human comparisons now drives millions of training updates on data the humans never saw. Boil it down, and 3 ideas define the reward model. The first is that it predicts human preference as a score. It compresses messy, subjective judgments into a single number that an optimizer can actually chase, which is precisely what the reinforcement learning step needs. The second is scale. A few thousand human comparisons get generalized into a signal for millions of updates, so human effort is spent once and reused endlessly. That leverage is what makes RLHF practical at all. The third is a warning. It is only a proxy for real human preference, imperfect and gameable, so a policy can over-optimize it, finding answers that score high but are actually worse. This is reward hacking, a form of Goodhart's law, and it means the reward model's quality, its calibration, and how hard you push against it all matter enormously. All right, let's lock in the essentials. A reward model is trained to score responses the way humans would, turning messy, subjective preferences into a single number an optimizer can chase. We build it from pairwise human comparisons, tuning it to score the preferred answer above the rejected one, using the Bradley-Terry objective. Once trained, it scores any new response automatically, providing the reward signal that the reinforcement learning step optimizes against, cheaply and at scale. Its central weakness is that it is only a proxy, imperfect and prone to over-optimization, which is why its quality is everything. Curious how the rest of AI alignment fits together? We unpack it jargon-free over at Standarity.com. Come join us.